G'day guys. Using the back camera on the phone this time. Damn it, I can't zoom in and out on the back camera, but oh well. I'll make the most of this as best I can. So I don't know if I can zoom. I'll try. I don't know if you can on this one. No, it won't zoom. Damn. Okay. Got an SD2100 here, and yeah, it's got a really weird fault. And I'll turn it on. I'll show you what the fault is. You'll go, hey, what's going on here? But anyway. These are notorious for this type of fault. Any of these detectors. So I'll just turn it. Don't you just hate that? Now, in my hand, I've got a magnet. Now, you can't affect the detector with the magnet, but you can affect the coil. And the coils, you can see where that red drawers is. There. The coil's way up there. So, but I've got a magnet here. This is just some magnets. Can you hear that? Well, let's go over here towards the coil a little bit, but I'm miles away from it. I'm about a metre away from the coil. What's it doing? Picking that up? What's going on here? So, what I was getting very funny, strange signals. Yeah, and I'll tell you about this fault, and it turns up all the time. So, if you've got one of these detectors, and I can't put the magnet down anywhere, it wants to stick to everything. Stick there. You got these 3 trim pots here. 1, 2, 3. And hopefully, I can always drop this down. It might be better. I'll just drop this down because it's pretty high up because I was doing the coil stuff before. So we'll go down. Okay, and I'll lock that. I'm going to have 3 hands to do this. Okay, and there it is. Now, there's different versions of SD2100s, there's different versions of SD2200s as well. And there's different versions of SD2000s. So what we're going to do, and I've got another one down here which I'm going to pick up and show you this one. This one here is an absolute mess, but please come up. If you can see on this one, you can see the pots here, nicely placed, nicely in a row. You got your yeah, you got your shorting pins between these capacitors here. You short these out and short that out, and then you leave that one open, trim that pot there, get rid of earth field, do the same, and just nullify earth field by banging a magnet round. Works really well. But we don't worry about that. That is one version of a 2100. That is a version. But this one here is earlier, and the potentiometers here, if you can see them, are basically somehow, I don't know what they were thinking, really, but I don't know how close I can get this in. I'll try and get a bit closer, but you know, if I'm using the front camera, I can't see what I'm doing, so I have to do it this way. Oh, there we go. So, yeah, channel 1, channel 2, and ground balance. That's your pots here. But what they've done, and I've chiseled away a hell of a lot of hot melt glue, and that's what they do. They solder them down somewhere on the pins of the ICs here, and then fill it up with hot melt glue, And what do you think happens over time? It decides that it wants to fracture the solder joint. And what I was doing, I was touching the board everywhere, and because this wouldn't ground balance. And I'm just thinking it was a ground balance problem. So what I did, I was reading one of the op amps here. It looked very, very strange on the input, like it was loaded down. So I replaced it, and that's on channel 2. Because it'll ground balance okay on channel 1. It's a good telltale, actually. And I've gone all over it on the channel 2 thing, through the filters here, all the way back down into the thing. Also, if you've got leaky input FETs here, if they are leaky, sometimes it causes it to non-ground balance in channel 2. Very strange effects. And also, behind the capacitor, there's another little surface mount down here, but I pointed it out in another video that can also cause this type of effect. Also, BS170 transistor here can play up as well. And cause this effect as well. It's really weird. There's a lot of ways this happens. It works in channel 1, but it will not work in channel 2. Also, a resistor down here can get a high open circuit and stuff like that. I think it's 560k, but don't quote me on that. But on here, after much poking around the circuit board, I finally got in and got rid of the hot melt gloop, and I pushed really hard on this IC here. And when I pushed down, well, guess what? It wasn't doing that weird magnetic effect. What I did when I was working on it, I just got a cable tie, put the magnet on the end of it because it stuck to it, and stuck a ferrite rod hanging out of the drawer up there, and just let it swing. And when it was swinging, this detector was going completely nuts. It was just, all over the shop. And I needed a source of something like that to keep this noise effect happening. And that's when I was playing around with everything. And, I was pushing down on parts with bits of wood, like my test stick, because you don't want to use metal because you've got to have it on. And as soon as I pushed down here, I could hear it in the audio amplifier. It was like, sounded like two metal rods rubbing together. It was like a staticky, sort of a staticky noise. And yeah, and what it is, it's this pot here, as far as I can tell, has come adrift from where it's been soldered onto the legs of that IC. But to do that, I have to remove the whole lot, and then I probably have to get in behind it somehow. So there's a hell of a lot of parts I'm going to pull off here. Actually, I'll just undo it. This had external pots fitted. I don't know if you can see that we put pots in there for the tune and tone rather than the silly little screwdrivery things. And yeah, I'll pick this up. I think I might have to do it this way. I hate doing this because the wires on these are very fragile and they can break easy. But if you can see, I've got to look at this to see what I'm looking at. There we go. You can see these capacitors here. We'll take those out, or probably that and that. But see, it's got hot melt glue in the middle. And then I've got to work in behind it and probably have to take out the strip there, or take out both of them so the board's flat. I can actually get in there to work on it. And hopefully it's just the legs on that pot that's gone haywire. I don't want it to be any through plates or anything like that are chewing out. That's really painful. You'll notice on these boards too that they are absolutely, I don't know if the cameras can zoom in good enough. Well, not zoom in, but I mean with enough resolution, that all these little black dots you see on the board everywhere, they're all through plates. They join a top track to the track on the other side. And so many cases you look at them and they're all green. They're all green around the through plate. And that means water's got in there, or just atmospheric moisture, and it's turning the copper into copper sulfate or copper something anyway, and it's not conductive. So if it eats all the way through a through plate somewhere, the detector will not function properly, and you are going to have a real hard time trying to find that through the white paint. It's an absolute damn nightmare. So that is one of the biggest issues with these detectors. The issues with these are mainly for reasons unknown and reasons that we can only speculate about. These two N FETs decide to, well, one will blow up, it'll go short circuit, and the other one will be okay, but it's probably been damaged as well. So you have to replace those, and it's got some balance resistors here, or dissipation resistors on those each MOSFET there, and also a 10 ohm gate resistor. They usually go up in smoke. You have to replace those. Occasionally, you got two diodes here, and they are meant to be. Usually, you hope they're still there, but they are the bleeder resistors for this cap, and that cap will give you a nasty bite because it can hold a big charge of 185 volts DC. And if you touch this, and then you touch the case of this, you're going to get a belt and a half. It's going to throw you off your chair. Be wary. These things are dangerous. So, and make sure when you put these things back together, put the plastic washer through this. So many people, this is live, and so many people forget the plastic washer and just bolt it directly to the case, and they can't work out why the detector don't work. Yeah, I've seen that so many times when stuff comes in. People have been in there and had a fiddle and put it back together wrong. Or the other one is they get this washer, spacer washer, and they put it under the head of the screw, which and have the tag here, this connector, the metal one, onto the metal of this, and also that will stuff your detector as well. It won't work. So there's so many times I've seen people pull it apart and completely stuff up putting this back together. The other thing, you got some 400 volt or 250 volt rated, or are they 200 volt rated diodes? Let me think. 2100. No, they're 200 volt rated diodes, 1 amp diodes. They are a fast diode. One there, one there. They can fail as well. That is the recovery circuit. We'll call it the bleeder circuit for the flyback. Goes through that diode. Goes through a little monitoring chip there, and yeah, basically turns this up and down. Acts as a variable resistor. Keeps the voltage constant in the flyback, and that's your reservoir capacitor. Very, very common. The other thing that happens, the power supply blows up in these too. If you can see here, I don't know if you can because I don't know if I can hold it properly, but you can see there's a MOSFET there, and one's a NPN transistor, ZTX 688 for memory, and one is a FET, and that is your plus 5 volt rail, because this is positive to ground and it steps up the voltage another 5 volts, and then uses normal battery voltage negative as -5. So it's like a pommy car. There's a high-speed diode and switch mode supply there. That there can go short circuit as well. These devices here, if you short anything out on the chips, it'll take these out. It'll just take out that switching transistor for memory. You can put anything. You put it, say a 2N7002 in there as a replacement. You can even put a surface mount in there if you want. They do that on the 2200s, but that's just a stand-up version. They call it, I think they call them, it's part of ZX, or diodes as they call themselves now. The E-line transistors, you can get them. The ZTX, that's ZX, that's what it basically stands for. So yeah, you got your voltage monitoring here. You can see that there's been rework in the design of this detector. They've looped on a loop here. On this is a 40106 for memory. I think it's a hex Schmidt trigger. I think it could be something else in there, but I think I've replaced it with one or the other. That's what I used in the design of the stud finders, 40106 chips, because of all the gates anyway. There's a capacitance measuring device for studs behind walls. Yeah, see little joiners everywhere, so there's a couple of goes at probably making the circuit board, but up here, this in here is anyone's nightmare, because you have to get in and under, and it's, like I say, it's all packed in with gunky glue. And that's the other device there that fails. That's little tiny. Look, I'm not sure on the value because everyone I've measured is different, but it is a capacitor for delay of switching. I think the P channel FET here from the 4093, and it causes a bit of a delay there. I think it could possibly be around about 1,000 picofarads or nanofarad. It could possibly be, it may be less, but like I say, every time I measured these when they fail, they're short circuit. That capacitor always is the one, no other little surface mount in here goes short circuit. That one, always that one, as you can see, that's been replaced. So it's just one of those things, and it doesn't have any voltage stress over it or anything like that. It just decides to go short circuit for whatever reason. So anyway, this stupid fault in here, annoying fault, has caused me grief. I had to replace this device here, this IC. I replaced this IC, and I even replaced this one here in the filter section because of the strange effects I was getting. I was saying, what is going on here? Is it causing something happening, going around, looping, something pulling something else down? And it made no damn sense. So, I was saying, come on, what is it? And I've gone down here. I've got my correct signals here on this device. I've got the inverted version on this one. That's how they do the ground balancing. They basically shove that in the inverting input, the output of this couple of resistors, and they've got a mirror image of this one out. This one's output to this one. So you look for the mirror image on those two chips, and then it goes in here. And these are your switches, your multiplexer. It's driven off this device here. Yeah, which is then comes off. It's controlled by your oscillator circuit here. Goes into this EEPROM, and that EEPROM address lines control this to what switches where, clocks down, and all sorts of things. And I'm not going to go into too much detail. And it just goes in here and triggers these on and off, and selects the output from these and shoves it into these at different time spacings and intervals. And that is how the ground subtraction works in this bit here. And yeah, earth field cancellation, and yeah, 3 amplifiers, channel 1, channel 2, and ground balance channel go in here. And as you can see here, just by looking at it, that only channel 1 and channel 2 go through the rest. You got a switch here. It's got some switch here that you can have it in the middle, and that selects whatever's loudest out of channel 1 or channel 2. You'll never get both at the same time, which I find is interesting. Then that gave rise to the warbler. Anyway, it's another story, and I think I've addressed it before. And you can select channel 1, channel 2. Otherwise, you won't be able to ground balance with your two ground balance pots because you won't know what you're doing. If you can't separate the channels and turn one off, well, then how you know if you're trying to do two pots at once? You'll just get confused. So it actually kills. You flick it one way, it kills channel 2. Flick it the other way, and that's that switch there, and kills the other channel. So then you got two pots, and you then adjust whichever one you didn't turn off. So anyway, I'm still here. These here, these pins are like the other pins. What you got to do is you got to use a jumper lead to a ground pin, and I think that might be a ground pin there, which I bent over because it was in the way. That's a ground pin there, and you put a jumper lead there, and what you basically do, short two of these out, and the one that's not shorted, you then adjust and bounce your magnet up and down, and minimize the signal, or the you minimize it, and then you change it and put it on the other two, and then find out which one that is and do the same, and then do the other two, and then the one that's not connected to ground, adjust that. So which one's which? Because it's all a conglobulation of glue, I don't know. I've got to find out, and I can't remember back after doing so many damn different detectors to what's what. So yeah, that's the big issue. So if I did push down on this chip hard, and or push down on this pot actually fairly hard, that the imbalance goes away. So I've got to dig in there and fix it. So that's a little bit of a thing about the 2100. Very, very similar to the SD2000. Very similar indeed. I think most of the componentry on this, what we call filter and audio board's the same. I think it's exactly the same. And this bit around here is different, configured differently. Well, not configured, but put together differently on this detector. I don't know what they were thinking. Why would you do that? Maybe when you first made it, you thought you didn't need trim pots. I got no idea. No, I'm just having a joke. But I don't know why. Why not make it like the previous, or the previous one of these I showed? It was all nice and neat in a row. Sort of a bit of a hack there. But anyway, yeah, you got your flat battery detection circuitry here. 2.5 volt reference for your power supply. It's just a diode, reference diode. What else we got here? Oh, gotta tell you, this is a beauty. Detector completely screams its head off. Won't behave. You measure your voltage on this FET here, and you got something like 240 volts across it. It's amazing. It has an avalanche and gone short circuit. And you go, why is that, right? Why is that? And I'll tell you right now what it'll be. That or that has gone open circuit. Normally, it's the first one. These are in series. And that is part of the circuit goes into this chip here that controls and regulates this thing here turning on to keep the voltage at a constant, whatever it may be. 185, depends on tolerances of the circuit. Could be 180, could be 175, could be 160, whatever. But that is how it regulates. And when one of these goes open circuit, normally it'll go brown. It'll burn through over a period of time, and you'll get massive high voltages. I mean, you don't want to touch that. And a lot of cases too, don't trust these bleeders here. They go open circuit as well. So you could get a nasty surprise. Always short this capacitor out with something insulated. Just bang, it'll make a big explosion if it's got 240 volts DC across it. Even 185, it'll still go bang. If you're in a room and you've got people around, they'll come and look and see what the commotion was. They'll think that you blew something up. It's very loud. So, yeah, that's failure mechanisms in this detector. Through plates are another issue. The front end is pretty robust. The input IC here, they're expensive. You can't buy these anymore anyway. You can get replacements out of Latvia, but they haven't got the same noise spec, but they'll do the same job. And they're a hell of a lot cheaper. I think, God, if you want to try and buy these on the second-hand market, they're very, very expensive. Yeah. Like I think I said on the other ones about all these damping resistors here, total overkill down the ground. Yeah, I'd chew all that out and put switched damping in there, but not in this detector. I just got to get it going for the fellow. And yeah, Don't mess these around either. You can swap them hard over one way and the other. Don't do one in the middle and one not. It'll blow up, smoke will pour out. Yeah, all sorts of funny things you can do with these. But that is the SD2100. Fairly straightforward to work on. If it was the other version, this is a dog's dinner. I don't like it. So anyway, I better hack into this and see if I can clean it up. But anyway, guys, any of you guys who want to, you find one of these doesn't work, I've probably given you enough pointers to fix it. I could go around the oscilloscope and show you like all the test points, what you're meant to see, and probe in other places, so you know that it's working up to a certain point. You can check the oscillator and stuff like that. The oscillator doesn't work, nothing will work, and yeah, power supply doesn't work, and nothing will work, and yeah, just need to know what you're looking at. But yeah, it's pedestrian in its design, which means it's a walk. It's not something super complicated, but yeah, just the white paint that makes it a bit hard to work on. They could have put a clear jelly on it. Maybe clear jellies didn't exist in the time of manufacture for these, but then again, they could have put on their other detectors and could have worked through it. But yeah, I'll see if I can come up with something better than that, because I don't even want to put it back together like that. I'll see what I can do. Anyway, it's starting to lose the voice. I'll kill it here and I'll get into it, because normally I'm going to stick my head right in. And when you see the back of my head, you won't know what I'm doing. But I'm going to dig out all that crud in there, fill it up with isopropyl alcohol. Just keep dosing it with isopropyl. It makes that hot melt unstick and basically fall apart if you get enough of it in there for long enough. So yeah, I better stop talking. I'm getting croaky. Catches.